now going to talk about production unit scenario. This is very specific to RailWheel factory at Bangalore. We are manufacturing wheels and axles for railway application at RailWheel factory, Bangalore. And the wheel is cast every 2 minutes. So wheels are produced by casting. We have a specialized steel, and we have electric furnaces with which we melt the steel and we cast the wheels. Axles are produced through the forge process, forge, and afterwards they are machined. Similarly, we combine and make wheel sets. So in RailWheel factory, basically three streams of product we are having: wheels, axles, and wheel sets. Now, when we are having a hot shop, what we call it, a forge unit and a casting unit, we do use up lots of water in production, which primarily goes for cooling. My project initially was focused on becoming self-sufficient as far as process water is considered. So in this plant, we were having a consumption of almost 3 lakh liters of water for the process. Overall, if you see water footprint of RWF, including 2 townships, was almost 13 lakh liters, out of which 3 lakh liters was exclusively every day was used for cooling, basically top up for the cooling furnaces. So these are, some water tanks which were part of the wheel production unit, and they were part of the cooling water system. This is a snapshot. We started this project in 2017, around February, March, April, around that time. And this is the baseline data for 2017, when we used to basically get cooling water from a combination of, we had an in-plant sewage treatment plant, but a large amount of it used to come from BWSSB. Of course, this was not fresh water, it was treated water only. We had 2 working wells, open wells inside the factory, from where also we were also drawing water. So this was the kind of mix of different type of waters, month on month, how much we were getting for 2017. If you see RailWheel factory, there's a satellite view of the plant. It is, it's in a area where you have Yelahanka Lake to the northeast of it. You have Puttanhalli Lake and Alalsandra and Chakur Lake. So when I started on these projects, I thought, there are water bodies around that. And besides that, we have the plant area is 191 acres. So if we take rainfall data, so the average annual rainfall data in Bangalore is almost a meter, 948 mm, and which is basically, if you see the volume which is falling onto the plant area only, 191 acres, it is almost 7 lakh kiloliters per year. So when I started thinking about, how to take care of the process water, this very clearly indicated that the rainfall itself is, even if I fraction of it, I kind of somehow capture it, it will be sufficient for my annual requirement of cooling water, which is just 90,000 KL. So another data which I looked into was, what is the maximum lean period based on 100 years meteorological data. So in Bangalore, it's 100 days, that means after 100 days, maximum lean period, some rain or other will be there. So then if you take 3 lakh liters per day and 100 days you want to tie over, then you have to have something like 30,000 KL storage capacity. But then after this, I kind of abandoned the engineering approach, and I took the traditional rainwater harvesting methods of, old times of, open wells, and trying to create some wetlands in the factory, which will make sure that these wells are always, yielding water. So luckily for us, our plant area had a low-lying area, which was kind of unused, left untouched. And this was having its own boundaries. One side on the north of it was the proper boundary, and the south of it was the railway track through which we were moving raw material and other things for manufacturing. So because of this, we had this nice low-lying area. Here you can see this green patch. and automatically some kind of geographical boundary was made. So we started working on this with the idea that we'll develop something like a lake here, which will collect the rainwater and it will keep on charging the wells. So this was the scene when we started this plant already, because it was a bit isolated area. It has started becoming a dumping ground. You can see lots of process waste is being dumped. This green patch in center, what you see, actually it's a water body. It's a wetland, a very small part, small, shrunken small. So we, if you see on the north of it, we have Putinali Lake and Yelahanka Lake, and here we have this low-lying area where we decided to work. There were basically two catchment zones inside the plant. One was axle shop catchment zone, another was wheel shop catchment zone. These were feeding into the low-lying area through two different routes. We also had another third catchment area, but initially we focused on the axle shop catchment area and tried to work in a manner that maximum number of water comes down to the low-lying area. And we had one open well here, somewhere here, another one here. And third one, people told me that well is there, but we could not locate for almost a month. After lots of clearing of bushes and all that, we could discover that. And there was another abandoned well here. So only two wells were open wells were working, and two were kind of in total disuse. So this was the first well which we started to revive. This is about a year back, before we started our project. You can see the condition. It's kind of all filled up all around, and process waste is also lying here. It was called Kandaswamy well, and it has kind of become a dumping ground. So this was the well which was kind of, it was yielding around 25 kl water every day. And here you see Vishnath sir. He also, visited our plant when I started discussing with him this project. So he was kind of excited to see this well. This well is quite big. It is around 10 feet, 10 meters dia and 12 meters deep. So he kind of, when he told that, you can easily extract out almost a lakh of liter per day from this well, that kind of excited me, and I realized that we are on the right path. In the background of it, you see the small wetland which is there. So this photo was taken in April of 2017. Immediately we started working on this project, and I set a target date of May end, so that June first week, when World Environment Day is there, we can kind of officially launch this project. So for almost more than a month, we started cleaning up this area. So this is the whole area of consideration where we're working, and this big dot circle here is the well which we were talking about. So first, what we did was, since it had become some kind of dumping ground, we told that, okay, this is a eco zone. We put markers all over the boundary and told that nobody should dump. And we formed teams which will go around and make sure, if anybody moves their vehicle that side, they'll be sent back. Then we started cleaning up in the month of May. We got lots of packing material, lots of rubbish and other thing lying. Luckily, we were having equipment, our in-house equipment, heavy-duty earth-moving equipment was there, which came very handy. I set up a system where in a week, for one day, this whole equipment will go and do a mechanical shramdan, you can say, for the that area for cleanup. So this photo was taken slightly after some time, and already lots of cleaning up has been done. And this is just before the World Environment Day. You can see the all the waste and all has been removed from this area. This is the open well, and this is the small wetland. Here also some wetland is there. What you see in the background is actually not in our boundary. It is Yelahanka Lake. It's a huge lake, almost, I believe, almost 400 acres lake. So what we had planned that on the day of World Environment Day, we'll connect these two small water bodies. So by this time, we had already moved almost 170 lorry loads of muck from this area, and we had, part of it could be disposed of, and part of it we had low-lying area, further low-lying area in our factory where we could relocate it. And the idea was, connect these two water bodies and enlarge it. So this is the formal inauguration of the project, and very interestingly, the moment we connected, water started flowing in that connecting channel. In fact, we were not able to see any water, but water started flowing, and that was like a very good sign for us. Actually, after this inauguration, the real work started. Immediately after we saw that, there was a culvert which was there for sending out excess rainwater outside. So next day we found that, all the water which has accumulated here, it started just flowing out because when we connected. So first thing what we did was we made a small check dam here so that the water will hold in this water body what we are going to create, and only excess water will go out. And after this, after rains, you can see this check dam was very effective. Here you can see through the well, water is filled up. Well is also full of water here, you can see. Then we started working on, clearing the water paths. Very deliberately, I did not choose to make any concrete water path so that, water when it flows, it will also get absorbed, as well as, after some time, lots of vegetations came in this water path. So the velocity of water will also break, and it will not go and destroy whatever we were creating, and it will also not build in silt, will bring in silt. So these water paths we created with JCB and other heavy equipment. This is a scene of that area after a week or so, about 10 days. We had started enlarging. Again, we were making something like a pond. Only we were just simply digging, and only edges we used to make sloping so that it will not collapse. And I just left it as it is so that the natural plants and all will grow over and take over this site soil and all. It will protect also. So this is somewhere in July, and there's another water path from axle shop, what we call this water path. Actually, we had to do a little bit of floor treatment because erosion was very high. So we some little bit of concrete, but sides we did not make any walls. After one of the heavy rains, I noticed that here actually the water used to take a 90-degree turn, very sharp 90-degree turn, and here the drop was very high. So there was a tendency for water to rush out and hit the boundary wall. After we have cleared off all the drains and all, I was a bit scared that if the boundary wall is damaged, then it will create problem. So we made this area only. We put some kind of stone pitching with it so that this road will not be destroyed, and in turn the boundary wall will not be destroyed. So on in July, first week after a month or so, we had already moved almost 270 lorry loads, and this is the scene. You can see water is already collecting around the well, and the plant area where you can see these plants. Basically, it is the old water body, and all the clear water portion is the new water body what we had created. To get an idea of scale, you can see there is a pickup which is lying here. In fact, this well is so deep that if you kind of take it out and lay it side by side, you can move a lorry across it without any problem. So after our project, this was the scene. Water is so clean, you can straight away drink this water, and uh, I think almost more than 80% of population of India will be very happy to kind of harvest this water. So this is the first well what we revived, and we had started from here and we finished here. So after we were through with this project, this well had started yielding straight away almost from 25,000 liters per day to it went up to 80,000 liters, almost 1 lakh liters we could extract on a sustainable basis from this well. So this was the first well which we took up, and after this we moved on to the second well. Second well, adjacent to it, actually, there was a water body, but it was totally dumped with the rubbish from the factory. You can see this place where the dumper and all is standing. We worked really hard for more than a month on this, and we created this water body at the same place. This is the photo of the same location after we were done with our cleaning up of this area. So deep inside there is a well. Actually, that was called Damodar well. That was our most yielding well. We were getting almost 70,000 liters per day from this already because it was in a very saturated water saturated strata. After the this remedial measure was done and water body was created, that also started giving almost a lakh liters per day on a sustainable basis. After that, we started moving to the third well. So okay, this is the Damodar well, second well. Then we there's a third well which we attacked after this. My people, the old people who were there in the factory, they told me that there is a well, and we almost took 1 month to discover this. It was covered with a very uh, heavy bush and other things, thorny bushes and all. Finally, we got to it, and we found it's totally abandoned. In fact, it had lots of rubbish inside it. We cleaned it up, and we started making a feeder water wetland or a small pond for this well also. This is how we created. We simply dug up and left it so that after rains, it will automatically after some time it will get settled and water will start holding. So here you can see the well which is taken out, and all around that we created a water body. After one of the rains, you can see the it's almost like pure uh, uh, rainwater. It's so clean, so good. And this third well also we revived. This was totally abandoned, so we had to put in new pumping arrangement and piping and everything. In fact, this water is so clean that one fine day when I was roaming around that, I found freshwater crabs. So one of my friends who's a bit naturalist, he told me ki freshwater crab, if you are seeing, that means the condition of water is really really good. After this third well was over, we started. Okay, so this is how we had started, and we had end up here. So then we moved to the fourth well. Fourth well was in this condition. There was a pipe; it was totally corroded, out of action, totally full of vegetation and other things. But actually, around this well, there was no water body. This well was on the other side of the track. So I decided to create a water body here. We worked a lot for this because probably almost 40 lorry loads of material we moved out of this and created a reservoir next to this well. So this is the condition of reservoir after we were done. Actually, it's not very evident, but if a lorry is standing here somewhere here, it is this depth is much more than industrial dumper height. So this was the scene after the first rain. Obviously, this was fresh earth, so it did not hold water. I had to wait for 3 seasons, 3 years for this reservoir to become, start holding water. After the 2 to 3 years, enough vegetation and other things were there at the bottom, which helped in holding the water. So, and we also worked on inflow for this this area because this area was normally not inflow area. So here is the water body, the reservoir what we had created. We started mapping the various water paths to this place. The third water catchment area of our marriage hall. There also we kind of intervened. There was a boundary. We broke the boundary, let the water flow in, and then go to this well. So this immediately after revival of this well. This well was not full time. The last two wells were smaller wells, so they were not always through the year. But when they were giving yield almost 10 to 20,000 liters per day, these two wells also would yield. So these were the four wells which we revived. And after, okay, this is the fourth well, which this is the condition when we started, and this is the condition when we finished. So after revival of, along with the revival of these four wells, we had to augment pumping also. Obviously, the third well and fourth well, we had to put in new pump. These were smaller wells, so we put 5 HP pumps there. In the older two big wells, 5 HP pumps were there. We added 10 HP more there. And of course, the piping and other things were added. After this, within I think 7 to 8 months, we were able to become water self-sufficient, and we got some good coverage in media also. This is what came in Bangalore Mirror, Deccan Herald, and of course, Vishnath sir has covered this project immediately after we had started. So this is an article he wrote in Hindu on May 27th. We had started somewhere in April. This is an article from May. After his article came, that gave me lots of boost to me, because sometimes I just used to roam around and, see, yeah, ab idhar kya karna hai? You do one thing, move on to next thing. And basically, it was like a slow motion landscaping of the whole area. This area was about, let's say, roughly around 20 to 30 acres, which I was handling and trying to slowly mold it so that it becomes a catchment area, and some kind of wetlands are developed there, which will feed into the four wells. So this is the coverage what he gave. There's a small clip which I want to present. Is the audio coming?
No, sir.
No.
Can you hear the audio?
No. No, sir. No, we are not able to. We are unable to hear.
Tej, can you tell him how to enable the audio first before he runs the film? Tej.
I think you have to enable computer sound. The
Right.
host presenting. One icon will come enable computer sound.
Yeah, there you are. Can you do that? You have to enable the audio, Ajay.
Just a minute. Let me see.
Enable computer sound, something will come like that.
Tej, can you tell him?
It's in
No,
the
it is
audio
written as
settings.
share audio. Yeah, it is written as a share audio. Just see the.
Yeah, share audio probably, and I also forget. It's good. Anyway.
1 minute. New share. Advanced sharing option. I think I'll just skip it because time is not more. It basically encapsulate the whole project in about 2 minutes.
Sure.
I'll just move on. So besides the water, this area, whole area developed as a ecosystem, very nice, thriving ecosystem. I used to move around a lot in this with my camera, and I captured all these pictures, snakes, butterflies. Of course, plant side also, lots of things were there. We had almost, I noticed almost a dozen type of different butterflies, half a dozen type of dragonflies. Of course, lots of birds were coming there, including some migratory birds and other things. We had a residential population of peacocks also there. So they also kind of grew after this project, and almost 25, 30 peacocks were there inside. We some fishes also there. There's a fisheries department in Hesarghatta. We got some baby fish and put in the water. This is one of the photos which I like a lot. This is in the biggest well, the Kandaswamy well. One day, two snakes and one toad, they got caught. It is a deep well. So obviously the snakes can't eat the toad. If they eat, they will just sink. So this is a good example of, surviving in distress. Now, my problem was, how to make the whole effort sustainable and, kind of uh, going on their own. So after this all was developed, I started bringing people from factory. Whenever their retirement was there, they will come and do a tree plantation there. So that there are two purposes. More and more people will come, and once they know tree plantation and those kind of activities are happening, they will not try to mess up with the whole area. They will not start dumping around. And of course, the people participation is there. For some time, we had a lean period in factory, so all people, we put them for doing some kind of a shramdan, because that area was almost for 25 years it was neglected. So we had lots of scrap and other things lying there. So we did a manual kind of pickup of scrap and everything, and we collected 25 metric ton of scrap, 5 metric tons of refractory bricks, and 10 dumper loads of scrap wood. All these were cleared in the second attempt what we did. And this is all manual. Within, I think, a week, we handpicked this much items from that area and made it further cleaner. So this is what we did for development of rainwater on a very mass scale by kind of developing newer wetlands around the wells and collecting the rainwater and using it in a sustainable manner.